My name is Josh.
Danny.
I'm Michael. And today we will be introducing the Sky Claw to you, which is the toy that we have been designing over the course of the semester. So, what is the Sky Claw? This is a powerful piece of equipment that your child will be able to operate, both the power to build and destroy, to create, to knock things over, to explore the environment that the Sky Claw can traverse, and also learn about a little robotics in the process. Basically, the concept for the Sky Claw came from the combination of several other toys, one of them being the claw machine you see at a mall, and we thought, well, that claw machine is pretty fun, but it's a very large object. It's an environment where you can't really expand the options of play beyond, trying to pick something up. That's a very simple play style, and we wanted to see something a lot more creative with the same sort of concept. So we combined that with something like a gondola car, or whatever they're called, the cable cars that are used for ski lifts and things like that. And so we thought, well, if we use that, we can move back and forth and combine that with the claw motion and get another degree of freedom and add to the options of play. And then we thought, let's just make this into a toy-sized concept so that we can use a crane, but beyond the cranes that exist currently in the toy business, it would be able to move over an area and actually allow the child to command the area that they're playing with. My problem with traditional toys is that you have a crane, but you have maybe like a square foot of space that you can actually work with that crane, and it really limits the options you have. Additionally, it's usually not the highest quality robotics. It's not designed to be a robotic thing, it's just a simple RC thing. So it's more of just like, you turn it around, you try to pick something up, it doesn't really pick it up because it's not very strong. And then you really just limit the duration that you can play with it. So we developed the Sky Claw to solve all of these problems we saw with things in the toy industry. And there we go. So we're going to go ahead and do a demonstration.
We're going to skip the videos because we got it here. So it's better. We're going to try to place an ornament on this tree that shows the Sky Claw.
So what you usually do to set up this toy is suspend it between two trees or two objects in your house with a line, and then it will allow you to move horizontally along that line.
You'll notice it's a little bit slow right now.
That's just moving at all.
Oh, it's not moving at all.
Line is stuck.
I think our line got off angled there.
I know why. Wrong direction.
User error when setting up the toy.
Right now.
Yeah, so
Stuck up there.
the toy has 3 degrees of freedom, with the first being able to move laterally along the line. The second being able to move the claw up and down, and the third being able to open and close the claw. So here you can see it moving towards the tree. We haven't actually tested this, so hopefully it does work.
In terms of the ornament, we tested the toy.
So there we go. If you really want to, you can use this to put ornaments on your tree. It may take you a while, but it would be fun in the process. So, there you go.
Obviously it's a little slow. We did plan for a more powerful motor. However, our ESC did blow up in the process of making it, so we reverted back to a servo to move it along. So it's a little bit slow right now. However, we think in the actual toy that would be actually in production, you'd be a lot faster, a lot more fun. So unique features of the toy. So we have 3 types of motion. We have the translation along the line. You have the claw raising and lowering, obviously, and then you have the claw opening and closing. We did explore other concepts for 3D types of motion, where the claw will be able to move in a 3-dimensional space instead of along just one line. And we do think it's possible. However, for this class, we decided for the final product to focus on the 1 degree freedom motion that you see here. We have a complex system of pulleys to facilitate the motion of the raising and lowering of the claw itself. These servos are independently controlled, also to kind of facilitate that 3D motion if we possibly wanted to, as well as the linear motion. So the geared claw was made out of acrylic parts, so we laser cut almost everything, and then 3D printed the rest of the parts as well. So claw, it's designed using spur gears. We used, again, all 2D laser cut parts with a 3D assembly, essentially stacked on top of it using some spacers and some other things. And we're using a high torque 120 degree servo to actually actuate that claw. So essentially, not only would you be able to use a claw here, we really envision this to be a kind of a play system. We thought of attaching a wrecking ball to it. So maybe you build a tower with the claw, and then you put a wrecking ball on it, and you can knock it down. Maybe adding things like an electromagnet or a regular magnet, a hook, or even maybe a laser pointer where you can try to aim things. Maybe you have the claw high in the trees, and you want to be able to see what you're going to be hitting. Things like that. We think it's really expandable, and it's a really cool toy concept that you could build upon as a child.
Okay, so there are obviously a few modes of play. It's more of an open toy. We were inspired by such toys that allowed you to use your creativity and imagination to actually expand the use. So obviously there's a constructive mode. You can use the claw to build things and move things. Destructive, we originally had a motor rather than the servo, so it moved faster. And we thought that one could add a weighted ball to have a destructive impact. And then obviously explorative. The movie Sandlot would have been a lot shorter if they had this crane, and they could have gotten the ball pretty fast. So, for example, that's just one of the many uses. This toy is usable to pick up objects, to build a tower, or really anything that you can imagine doing with your own hands. You can now do with the claw. And like we said earlier, it's kind of more of a passive toy than an active toy. It's not, so physical, but it definitely promotes more of a technical creativity for children. It's definitely for the nerds out there, but I guess we all consider ourselves nerds, and so I think we would have enjoyed this toy as children. It also facilitates group toys and is somewhat modular because you could replace any of the motors. It's all somewhat open source, I would say, design. And so in that spirit, it's more of a mental play style. You can manipulate an area with a set of building blocks, which we considered. I guess we would say that our toy, the ages is supposedly 6 to 10, but I don't know, I've seen adults play with Legos, and that's supposed to be 8 and below. So I would say that this is really, doesn't have a limit in terms of age uses. And I guess it's also slightly biased towards males, and that's mainly due to the color scheme. But it's really anybody it's for anybody who's creative and enjoys the technical toy. So that's the detailed design.
Next questions? Price range? So this probably cost us.
I try and think of the parts on, because we bought a lot of parts that weren't on the vehicle.
Yeah.
Probably spent around maybe 80.
I would say it would probably go between 250. Right.
No.
Well, if you marked it up.
Yeah, I guess. I think it's less than $100. I think it'd be less than 100. It's like an RC car essentially, with the amount of motors it would have.
I'm sure a lot of what we used was quite a bit higher end. So a lot of servos on there were taken from like our personal collections. And they're digital servos where you could replace them with a gearbox and a DC motor, which is what we intended for the X and Y direction. However, because our ESC burnt out during testing yesterday, we were forced to last minute switch to a servo to control the movement of the whole body.
Yeah, so the design definitely has space to be optimized to the point where you're using minimal materials and the least quality servos that you can get away with. Any other questions?
Right. We had an idea too, maybe mount a camera to it so you can see what you're going to pick up as well. That was the original idea.